But what is a function? A function is a block of code that can be invoked with a single word. And it may have parameters. It may have things between the parentheses. It may have a return value. So I'm going to have you all write some of your own functions. I'm going to demo them first. You know, the idea behind a function is you essentially have, a piggy bank. It may take something in. It may spit something out, You may pass a string in and get a number out, and you may have to put in two strings, you may have to put in two numbers, and nothing comes back out of it, But it's a black box that has some holes in it where you can put your data, and then it's got a mouth slot where it can give you the result. That's probably a dumb way to think about it, but that's what a function is. So you put your block of code inside the function, you decide whatever it's going to have to take as input, and then you decide whatever it's going to give out as output. So I could say things like this. Write a function that takes no parameters and returns 3.14159. Call the function getPy. Then I can say write a function that takes a string and adds the words "is awesome" to it and returns it. Call the function awesome. All right, let's do the first one. I'm not even in idle right now, so I guess I'll copy those definitions and put them into idle. And since I'm going to redline them, put pound signs and hashtags in front of them. Okay, so the first one, write a function that takes no parameters and returns. So what's the keyword that you use to define a function? Do we remember? Let's go back here. It's the only word in green.
Def.
Yeah, def. Okay. So we're going to get bigger and deafer and use the DEF keyword. My 1980s rap jokes don't go over so well anymore. I'll try to come up with new ones. Okay, so def, what is our function supposed to be called? GetPy. Does it take any parameters? No, so put nothing between the parentheses. And then functions have to end in a colon. Now this one's easy because all it does is return a number. Return 3.14159. All right, now the next one. Write a function that takes a string. I didn't tell you the name of the string, so why don't we add that to our specs? Called name, and adds the words "is awesome" to, and returns it. Okay, there we go. So, what's the first word? DEF. What's the function name supposed to be?
Awesome.
Awesome. Does it take any parameters? When you see the word takes a string called name, that's a way of saying that it's a parameter. I could rewrite it to be more specific and say it accepts a parameter that is a string called name. All right, so our function declaration is getting longer, but it's getting very specific. Okay, so does it accept a parameter?
Yes.
Yes, it does. What's the parameter called?
Name.
Yeah, and we have to have a colon. So it adds the words "is awesome" to our name. Name plus equals "is awesome," and then return name. Now we need to test our functions. So I'm going to add but I'm going to call some main code. I'm going to write a function called main, def main, colon, and all it does is test these two functions. Print, no. Pi is equal to get pi. A is equal to awesome possum. Feel free to choose a different name than possum. And then let's print pi, and then let's print A. Now all we've done is define a bunch of functions. If I run this program, nothing's going to happen because there's no code that's not inside a function. So at the very bottom, I have to call main. I'm going to put a call to main that'll actually run the program. And there's kind of a reason that I've done it this way. It helps the program, it helps Python check the syntax if you put all your code in functions and then invoke it with one line at the bottom. And beyond that, when you go on to program other languages like C, C++, Java, that kind of stuff, they do actually require you to define a function called main. So I'm just getting you used to seeing main inside your functions, inside your code. Alrighty, I'm going to test it. Run module, but I have to save it. Don't save it to your Python directory. I'm going to call it test functions. And it printed out 3.14159. Possum is awesome. I'm going to shorten my comments so that I can get all of this code on one page. Alright, so if it's a simple function, I ought to be able to describe it in a single line like that top one. Write a function, get pi, that takes no parameters and returns 3.14159. That's about the simplest function. Okay, so I'm going to add some function declarations that I want you to write yourself, and then I'll come back and I'll write them for you. And I'll also wander around and make sure that you already got the ones that we had up here working. Write a function named hello that prints howdy and returns nothing. If it returns nothing, you don't have to put a return statement in it at all, or you can put the word return with nothing after it. Alright, there's one. Write a function named double. It accepts a parameter named x. It returns 2 times x. Write a function named add. It accepts x and y as parameters. It returns x plus y. Okay. So work on those 3 function definitions. I'm going to wander around and make sure that syntax errors are not bedeviling us. How are we doing back here, guys? Yes, sir. All right, show me back. Spelling. Osmonia is the best one there. There we go. Anybody else stymied by typos? So like in that first line, if I say write a function named hello and I don't put that it accepts no parameters, or if I don't mention parameters, you can assume it doesn't take any. So that first one, hello, doesn't take anything between the parentheses. Also, if you write those three functions, once you write those three functions, go back down to main and add some code that tests them out. If you can't do that, that's okay, but take a stab at it. So here's the solution for the three functions. From there to there. Pause it if you need to. You can type them in then for future generations to benefit from this. Then we go down to main and we add this code to test it out. We call hello. We call our double function. We call our add function, and then we print the results out. So if you're watching this at home, pause as well and test it out. I'm going to test it out here. Okay, it looked like mine worked. I doubled pi, so b is equal to the double value of pi. And if you'd already written your own test code with different results, that's totally cool. And then c is equal to pi plus 2. So it looks like that worked. Let's see if I can do this again. I'll put the thing right here to remind myself to start it again. So let's see, I'm going to add some comments. I'm going to put my name up here. Jeff Thompson. What does this code do? You know, today is March 23. Write some functions. Then I'm going to go down to the bottom and describe what main does. Since every other function has a description, main will test the functions and print the results. There's a drop box called in_class_h. It's got a copy of all the code we've typed in, so if your code's not working and you need to compare it to something, you can do that. All right, I think we're pretty much done with the functions chapter. We've got the idea, right? We know what input, we know what parameters are. Parameters are the things between the parentheses. We know what the return statement does, you know, and the rest of this chapter here just goes into some detail about making complicated functions, like using, here's a compound interest formula, where you passed in the principal, the interest rate, the number of years, you know, and whatever t is. And then it does that interest rate formula and it returns the answer, you know, what your interest was for that amount of time. So this is all very good if you're trying to figure out how much interest you're earning, but if your accounts are like mine and you don't earn any interest, then all right, let's go look at a glossary. An argument. When you call a function, the things that you put between the parentheses are actually called arguments. It's like in your piggy bank, you're putting a coin in, that coin is the argument. But inside the piggy bank, it's called a parameter. Kind of a weird distinction, but when you're programming the function, the things between the parentheses are your parameter variables, but when you call it, they are called arguments. That kind of gets mixed up. I will use one word and the other, and I'm not going to ever ask you to specify the difference between the two. All right, the body. The body is a sequence of statements that is indented, underneath the function. Flow of execution. The flow of execution is the order in which code runs. If we go back to our program, where does our code actually start running? What's the first thing it really does? Yeah, it runs down here looking for some code to run. And the code that it runs has to be not indented, which was Ginny's problem. She indented the call to main, not to call you out. Some random person in the class tabbed main over. So anyways, what it's doing is it's scrolling all the way down here, keeps defining function after function, and finally it finds something that's not indented. And that's where the code started running. So the flow of execution started here, and then it blips up here. You think of code as running top down from the top of the file to the bottom, but in this case we're kind of running bottom up. We call main. Inside main we call getPy. So the code runs up and runs that function and returns. And then we call AwesomePossum. The code runs up there and returns. We print out two things. These are built-in functions. They look the same as the ones we wrote, but the editor colors them purple just to let us know that they're built-in functions. Then we call our hello function, so it scrolls up to wherever that function was implemented, and it comes back. Then it calls two more functions, and then it prints the results out. So really, this is skipping all over the place. It's always kind of top down, but it's only top down from within the function itself. It looked for the first line of non-indented code. It found it. It was a function call. So inside the function, it started going top down. But each time it saw a function, it had to pop up somewhere else, run that code top down, and then return back to here. So I hope that's pretty clear. That's called flow of execution. You'll hear that word sometimes. That's what it means. A function is a named sequence of statements that perform some useful operation. Oh yeah, what if I want to make it a useless operation? Anyways, functions may or may not take parameters, and they may or may not return a result. A function call, that's the call that executes the function. In my code here, I called several functions down here in main. I called getPy, I called awesome, and all the other ones. These are the function calls. They don't use the def keyword because they're calling functions that have already been defined. You can use the output from one function as a parameter to another function. It can get kind of yucky looking if you do that, but for example, and that's called, or anyways, he's calling it function composition, using the output from one function call as the input to another. I'm not going to ask you what function composition is, but you need to be able to recognize it when it happens. So for example, down here I could do print add double getPy. You don't have to type all this, but it's fine if you do. Comma 10. There. I may have gotten that all right. I don't know. That's really hard to follow. I don't recommend trying to cram as many function calls as possible in one line just because it makes it hard to do. But what happens? Well, you look for the innermost call, which is the one inside the most parentheses. So here, getPy is called. It runs getPy, it returns 3.14159, and then that is used as a parameter for, you go outside those parentheses, you find the next one, double. So now double is being called with the return result of getPy and 10. No, that's not right. Then we double pi. So pi becomes 6.2, whatever. You can see why I say it's not a good idea to try to cram as many as possible in one. And then, so the results of the double function are passed as one of the two parameters to add. And then all that is returned and it's passed as a parameter to the print statement. This may actually work. I'm just curious if I got it right. And it did. It gave us some answer. That's a little bit too much. You know, doing a little bit of that is okay. you know, you could do this, get pi returns, you know, comma, get pi. That's pretty clear, right? You know, you're calling get pi, it's returning a value, and you're using that as input for another function. But by the time you start, you know, cramming more, you know, it's getting like 2 or 3 levels of nesting, it gets hard for us to read. And so what I would do is I would do just what we did here, store the function return value in a variable and then use that variable as a result in the next function call. But that's function composition. Function definition is when you define it. A fruitful function, I'm never going to ask you what a fruitful function is, but it's a function that returns a value. I don't know who made that up. I'd never seen that before I read this text. The header line. The header line is the line that defines the function. Begins with the DEF keyword and ends in a colon. The lifetime. Variables have lifetimes. They are created and then they will be destroyed. What does that mean? Well, what if I used a variable up here to solve one of these problems? I'm going to go back up to hello, and I'm going to make something that says word is equal to howdy. And then I'm going to print word out. All right. So this variable gets created when hello is called. We store a value in Word. We print that variable out. We return. Once we return, that variable no longer exists. Poof, it's gone. The memory that was used to hold that data is gone. The next time we call hello, that variable is recreated. And it is used, and then it is forgotten again. The memory is released. That's called the lifetime of the variable. The lifetime of the variable is generally everywhere after it is defined until you unindent. So this variable is defined all the way from here until we stop indenting. And I could give some other examples, but I'm not going to bother. Well, the lifetime is also in other languages known as the, oh, my brain just flaked, scope. Scope. But this text calls it lifetime, so I will try to refrain from using the word scope, but I just want you to know when you go and take Java or C, you're going to hear the word scope. And I want to see all of y'all in my Java class next semester. Every last one of you. I'll come hunt for you. No, I'm totally kidding. Alrighty. Alright, here's a really fancy word, refactor. Refactor is a fancy word to describe reorganizing our program code to make it more understandable. Usually you refactor a program that is already working. So what does refactor mean? Well, refactor means maybe you're going to, make your variable names be more meaningful. Or you're going to make your function names be more meaningful. Or you're going to reorganize your code so that, main is below everything. So if I decided that the name awesome was a really stupid name for a function, I could change the name of the function. I could come up here, find the awesome function, and call it something else, something even more stupid. I am awesome. But if I do that, the code's not going to work anymore until it says name. Awesome is not defined, and it gives me a line number. Why is that? Because down here, I'm still calling it awesome. But up there, I change its name. I would have to change it here. I am awesome there. That's refactoring. It's just trying to make some changes that'll make the code better, and you do it to code that is already working. You're just trying to make it clearer to read. Y'all probably won't be doing a lot of refactoring at this point, but when you're a professional programmer, you will, because the first thing you do when you write a program is to get it work. And then the second thing you try to do is to make it efficient and to look good. Why don't you try to make it efficient first while you're writing it? Well, you can spend so much time trying to be clever that you never get the program to work. It's more important to get the program to work and then figure out what the holdups are, where it's taking the most time while it runs, and then you can correct those. And in other programming languages like Java and C, there are tools called profilers, and they'll tell you which function it's spending the most time in, and then you can go and you can try to optimize the code to make that code better in that specific function. Everything I said there is very important, but it's not going to be on an exam because that's more software engineering than learning to program. Oops, I did not mean to launch Visual Studio. Please go away. A void function. We never use the word void in this language. You do in other languages like C++ and C# and Java. But what a void function is it's the opposite of a fruitful function. What did we say a fruitful function was? A fruitful function is one that returns a value. So a void function returns no values. Maybe I do need to use the word fruitful. But let's look at our code and decide which ones are void and which ones are fruitful. I don't know why I say that word. I just don't like that. Okay. Is this word hello? Is this function hello? Is it void or fruitful? Yeah, it's a void function because it doesn't return anything. Y'all get the idea. What about this one? Double. That's a fruitful function because it does return something. All right, so forget what I said about me not asking about the word fruitful. Do remember fruitful. Just because this would make an awesome test question. Is this a void or a fruitful function? Well, this one is a void function. This one is a fruitful function. This one's also fruitful. Do we have any other void functions in here? Well, this one returns a value, so it's not void. This one returns a value, so it's not void. What about main? Main is actually a void function. And that's true in some languages and not others. Print is probably defined as a void function because why? It doesn't return anything. I doubt that they made it return anything. I'm real curious now about whether it returns anything, so excuse me while I test this. I'm going to do x is equal to print hello, and then I'm going to print x just because I'm curious what it's going to return, what it's going to display. X was equal to none. Okay, cool. Apparently the word return by itself is the same thing as return none. In other programming languages, none is called void, but okay. We could use the keyword none if we wanted to be really pedantic. Return the none keyword is obviously not necessary because this code was working just fine without it. Exercises, write a program to draw this pretty pattern. Hey, that's pretty cool. We're not going to do it, but it's cool. Yeah, we could spend several more days just doing all of these. I should assign these as homework. By tomorrow, get all of these done. But nah. You have the idea of functions. That's what's most important. All right, next chapter. Conditionals. All right, so far, this program that we wrote today doesn't have any conditionals in it, meaning it doesn't respond differently to different values. But our dice game did. You know, if you rolled a 7 or 11, something happened. If you rolled boxcars or 2, something happened. You know, all of that kind of stuff are conditionals. Those are when you have conditions that you need to test in the program, and the program will respond to them. So here's a sample conditional. You know, x is equal to input, enter your name. If x is equal to Joe, print Joe is the best name ever. That leaves all of us out, huh? Okay, anyways. That's a conditional. This is a conditional expression right there. We are checking to see if x is equal to Joe. Double equals means you're doing a comparison. It's a conditional rather than a single equal, which means assignment. That's why that is known as the assignment operator. This is a conditional. And you do this in order to make some parts of the code optional. If X was not equal to Joe, it wouldn't print Joe is the best name ever. It would just skip it. And you can also have else statements after that. Like else, colon, what are we going to do if our name isn't Joe? Print, I wish you were named Joe. Now, who say we can't write useful money-making programs here? Alrighty. So I run it. If I type in Joe, it's going to do one thing. If I don't type in Joe, it's going to do something else. So I run the program. Now let's say that I forget that it's looking for lowercase, because it is. You know, I made the word if X is equal to Joe, I made it lowercase. So what happens if down here I say Joe in capital letters? What is it going to print? Yeah. And the reason it's going to print I wish you were named Joe is because uppercase letters are not the same as lowercase letters. Now there's certainly something we could do to convert our input to uppercase or lowercase, you know, to make our comparison better. But programs are so picky, you know, or computers are so picky. They want an exact match unless you have some way of specifying otherwise. So a Boolean value, a Boolean expression, it's one that's either true or false. It's named after a British mathematician, George Boole. If you have taken discrete math, you probably have already heard the name Boole or Boolean. If you don't take discrete math, then well, now you're hearing it. So at its simplest, a Boolean variable looks something like this. Y is equal to true. Not try. Okay, there we go. And then I could do something like this. If Y, then print Y does equal true. Else, print Y doesn't equal true. All right, we know which one it's going to print. This is true. This is a Boolean value. Now inside here it's being treated as an expression, but it's true, right? Because we just said that it was true. So it's going to print out Y does equal true. Here it's going to print out Y does not equal true if we change this to false. I'm going to comment. No, I'm not. I'll live with it. I just have to type something every time I run it. Okay, enter your name, Joe. Joe's the best name ever. Y does equal true. Now that is a really dumb use of a Boolean variable. But what you could do is store a comparison like this in a Boolean variable and check it later. We could do this. We could make a variable called name Joe, or named Joe, is equal to X is equal to Joe. And then we could do if named Joe. All right, I've only got like 30% of the class looking at the screen. I consider this pretty important, so I want you to take a look at it. What does this line do? It checks to see if our input is equal to Joe, and that's a Boolean expression. So either true or false gets stored in that variable. And then based on that, we can do our if statement to decide whether we have the best name ever or whether we wish we were named Joe. So the code works the same way it did before, but this sets a variable, a Boolean variable. Another word for that is a flag. People sometimes use the word a true-false variable as a flag. You know, we're going to flag whether our name is Joe or not. So this is using a Boolean variable. We calculate the result of the Boolean variable, and then we make a decision based on it. That kind of maybe makes the code look more complicated than it did otherwise. But you could do things like this. If, and by the way, you don't have to put parentheses on if statements, but you do in other languages, and that's why I'm doing it. If 6 is greater than 4, do something. Print greater. But we could do that comparison beforehand. This would be the same. G is equal to 6 greater than 4. We could even put parentheses around it to show that it's the exact same thing as what we were doing here. And then we could do if G. So this is a Boolean variable that's going to hold the results of this comparison. Not G greater than 4, 6 greater than 4. All right, we're going to make it a little bit more complicated. A is equal to 3. G is equal to 3 greater than 4. If G, then print greater, else print less than. What will it print?
Less than.
It will print less than. Here we go. A is equal to 3. Oh, dang it. I left that 3 is greater than 4. That was supposed to be A greater than 4. Yeah. You did what I meant. But not what it said. Okay, so A is 3. Is 3 greater than 4? No. No. So this is false. False gets stored in G. We come down here and we use G as our test expression, our conditional. So this is false. So we're not going to print greater. We're going to print less than. There's all sorts of comparison operators you can use. That one tests for equal, but you just saw me use less than. There's also greater than, there's less than equals, there's greater than or equals, and then there's not equals. And those work about the way you would expect. If A equals 4, print equals 4. If A less than 4, print less than 4. If A is greater than 4, print. I need to just cut and paste this code. Greater than 4. If A not equals 4, print not equals 4. And then lastly, well, not lastly, there were two more. If A is less than or equal to 4, print greater than or equal to 4. I'm forgetting my colons. And somebody said something. Pardon me?
You don't have to do an else thing with an if thing.
You don't have to do else's. Here, I'm not doing else's because I'm saving time. I'm saying, you know, I could add this to it, else print not equals 4, but I'm just going to, you know, kind of skip that. And then lastly, A is less than or equal to 4, so we're going to say less than or equal to 4. Okay, let's change the value of A. A is no longer 3. A is equal to 4. Okay. So let's run down this line by line and you tell me what's going to print. So A is equal to 4. Is it going to print this line?
Yes.
Yeah, because this A equals 4 is true. Is A less than 4? No, not really. We have to use less than or equals to for this to be true. So it skips that statement. Is A greater than 4? No, because 4 is not greater than 4, so it skips that statement. What about A not equal to 4? It's going to skip that one because A is equal to 4. So far, we've only run this one. Now we're going to hit some more that we might run. Is A greater than or equal to 4? Well, it's 4, so yeah, it's going to print that. And then is A less than or equal to 4? Okay, that's the idea behind that. So On an exam, I could do something like this. Give me the results of these expressions, 3 less than or equal to 4 minus 1, 5 not equal to 10 divided by 2. Stuff like that. And you just look at that expression and you tell me whether it was a true or false. Or I might do that. I might store it in A and then ask you to tell me what A would be. And rather than run to Python and type that in, and find out right away, just eyeball it. What is 4 minus 1? It's 3. Is 3 less than or equal to 3? Yeah, so what's going to get stored in A? True. Yep. 5 not equal to, well, here we have to figure this out. What's 10 divided by 2? 5. Is 5 not equal to 5? That's a false. So here we're going to store a false into A. These are all very familiar to us if we've, done math in prior, elementary school or high school or whatever, less than or equal to, greater than or equal to. The only one that's different is this not equal to. What we probably did was greater than or less than. I think that's what they used in grade school. So logical operators. You can make more complex commands with and, or, and not. So we're going to say age is equal to 30 and weight is equal to 400. Now we're going to decide whether we're ready to run the marathon. Well, let's store the result in a variable called m for marathon. M is equal to age less than 90. You're not supposed to run a marathon if you're greater than 90. I mean, you can if you want, but just for theory. And weight is less than 250. That's our cutoff. We're worried about people who weigh more than 250 pounds running a marathon. And again, I'm just being silly. Okay. This and means that we get true only if both sides of this are true. We are only qualified to run in this marathon if we weigh less than 90 and our weight is less than 250. So what's m going to equal in this case? Well, let's figure it out. Is our age less than 90?
Yes.
Is our weight less than 250? No. So m is going to be false because for m to be true, both sides of that logical operator would have to be true. Now let's write another one that uses or. N is equal to age greater than equal to 90 or weight is greater than or equal to 250. Okay, is our age greater than 90? No. But or means that only one of them will set it to true. If this part is true or if this part is true. So is our weight greater than 250?
Yes.
Yeah, it is. So since this one was true and we were using an or statement, n is true. Let's add a little comment here. M is false, n is true. All right, I'm going to make another one called temperature. I'm going to set it equal to 54. And then I'm going to make one called freeze. And we're going to do it in Fahrenheit. So we freeze at 32 degrees. And I'm going to make one called boil. And we boil at 212. See, Celsius makes a little bit more sense because the freezing point is 0 and the boiling point is 100. So if you really cared about those temperatures, then Celsius, that's why they use Celsius in math. That's one of the reasons. But anyways, okay. So we're going to make one that says liquid is equal to, and how do we check to see if something is a liquid? If its temperature is less than freezing and its temperature is greater than boiling. Now that's not right. I worded that completely wrong. What's wrong with that? Yeah, it has to be above freezing and below boiling. So, you know, I was rattling this off the top of my head, but I did it wrong. There we go. Okay, so since our temperature is 56, is liquid going to be true or false? Well, let's do it. Is our temperature less than freezing?
No.
Did I say that? Temperature greater than freezing, temperature less than boiling. I don't know why I'm spacing out on this. All right. Okay. So, is our temperature less than freezing? Greater than freezing. I'm going to go home. All righty. Is this part true or false? I'll just stop saying the words. That part's true. But we have to check the second one as well because this is an and. Is that part true? Yeah, so liquid is equal to true. Let's make another variable. I'm just going to call it x. Temperature less than or equal to freezing, or temperature greater than or equal to boiling. What is x true or false? Just eyeball it for a second. Raise your hand if you think it's false. Raise your hand if you want to go. All right, it's false. Why? No, it's yeah. Is temperature less than freezing? Is 56 less than 32? No. Is temperature greater than boiling? No, it's not. 56 is less than boiling. Since both of these are false, or is false. All right, so the last thing I'm going to do is we're going to make up a little chart about and or. Dadgummit. Lesson learned. Do it the other way next time. Okay. So, false, false. We're using and. Is false and false going to produce a true or a false? Yeah, that's a false. Another way to think about that is if it was worded like this. You know, result is equal to false and false. How about false and true? Is that going to be a true or false in the result column? It's still going to be false because both values on either side of the and have to be true for it to be true. How about true and false? False. How about true and true? True. Now we're going to do the same thing for or. Result is equal to false, or whatever, you know, x or y. All right. False or false. What's the answer? The result is false. False or true? True. Why? Because at least one of them is true. How about true or false? That's a true. What about true and true? Yeah. There's a sneaky one called exclusive or as well, but we're not going to talk about that. Oh, I'll talk about it. Exclusive or means that one and only one of the sides can be true before the result is true. So false or false, excuse me, false exclusive or false is false. True exclusive or true is false. Because exactly one side has to be true before exclusive or is true. All right, gang, we're done. How many people already have their smiley faces done? Cool deal.
Turn in, is it 8 class 8?
Yeah, I don't have a Dropbox for it. I'll make a Dropbox before I leave.
You do have a drop.
I do?
Yeah, you just made it.
So you have to-
Oh, but I didn't put any instructions in it. I don't think.
Do you want us to post the function?
Thanks for helping me with this.
Yeah.
I don't care if you just send me a screenshot or if you send me the code. Either's fine. Hi. Pardon me? I called roll. Remind me your name. Okay, I'll set you as true. I mean, as there. I'll set you as true. God, what a geek. Yeah, I'll set you as here. Yeah. Let me look. Have you logged out or? Okay. All right. It said named Joe is not defined because you
And I put that in at first, and then
didn't
like,
have
still
that.
didn't.
Yeah. Okay. This has to exactly be that. Maybe there was a uppercase letter or a typo.
Okay.
Because, you know, I saw people doing things like get PT rather than get pi. You know, it's easy to make typos or whatever.
Okay.
But if I didn't have named Joe here, or if I misspelled it, you know, named Joe, then it would say it was not defined. Because that variable has, oh great.
So I guess I'm just like wondering, like, how do you, like, what is exactly doing up at the top with the, how's the X in the middle there?
Sorry, I'm trying to get this back to a working state.
Sorry.
Then I'll answer your question again. Okay, it blew up because Joe was not defined. Alright, yeah, apparently I've made a lot of mistakes in this code since then.
I actually did it on a separate piece of paper, a separate thing.
There we go.
rather than it.
That's what I should have done.
Okay, so.
Let me
it's
make
true.
absolutely sure it works. There. So if you were typing along with exactly what I had, I definitely had a typo in it. My typo is I didn't have quotes around the word Joe.
Okay.
So when I ran it, it said Joe is not defined. You know, it looks like it's going to be good code, but it's not because there's no variable named Joe.
Okay. Yeah, that was my question, because I typed it in like that, and I was like.
And it didn't work. I'm sorry about that. My mistake. Sure.